Our experiment is titled Performance Analysis of Dedicated Servers in AWS Cloud Computing by John Bessie, Richard Northcutt, and Joe Torino. Cloud computing services like Microsoft Azure, Google Cloud, and Amazon Web Services are becoming popular because of their on-demand availability, customizable service options, and scalability. We sought to compare the performance of AWS Elastic Compute Cloud, also known as EC2 virtual instances, to dedicated servers with similar hardware specifications. The distributed and hypervisor automated services offered by AWS EC2 instances differ to the single computer and user-directed dedicated servers. We ran the Performance Benchmark Suite sysbench to test CPU, thread, mutex, input-output, and input-output operations per second performance on a selection of AWS instances and dedicated servers. Network performance was tested with Speedtest's command line interface app. Our goal was to quantify the performance differences. This data would allow direct comparison of the systems, which would be useful for judging the applicability of each for performance-intensive tasks, and to provide a metric to include in pricing evaluations of these systems.
Our methods involved analyzing individual system benchmarks on actual hosted servers as well as virtual servers from Amazon Web Services. The bare metal systems used were various comparable offerings from NOCIX, Reliable Site, and Hetzner. These three providers offer affordable, dedicated servers for businesses and consumers. Hardware specifications, operating system, and testing software were controlled for each AWS and dedicated server instance. Hardware specifics are included in the tables provided. For this analysis, we utilized Sysbench, which tests CPU, memory, storage, and network performance. More specifically, tests were conducted for CPU, memory, threads, mutex, I/O, and IOPS, with those metrics divided by monthly system price for easier interpretation. Test iterations were conducted either 1, 2, or 5 times, and those results were computed from the averages of the total number of tests. The most important performance metrics conducted during our methods were raw CPU tests, I/O tests, and IOPS tests. The results of these 3 tests give the end user an accurate indication of overall system performance and the general cost of that performance.
For the results tables, consider every group of 6 as a set, with the 3 bars on the left representing AWS and the 3 bars on the right depicting the dedicated servers. With this in mind, in all Sysbench CPU, memory, threading, and mutex tests, the dedicated servers came out on top. The FIO benchmark test was unique in that the EC2 instances all used the same default elastic block store, where the dedicated servers served only to test a traditional hard disk drive, solid-state drive, and NVMe SSD. So, this was a test of disk drive types against EBS, since the 3 AWS EC2 instances represented EBS similarly. This demonstrated that a traditional hard disk drive is weak when compared to the elastic block store, while the SSD and NVMe performed similarly and even better than EBS. The network speed test was one case where the default non-upgraded option for the dedicated servers fell short of AWS. Dividing each benchmark by the respective monthly costs, this price performance metric seemed to indicate a match or superiority on the dedicated server side. This leads to a conclusion that while AWS is a known cost saver for something like an infrastructure deployment by the cost-cutting elements of removing infrastructure teams, for example, these cost-saving elements don't apply in this scenario. Therefore, the dedicated servers are better and better suited for application deployment on an individual scale.